Okay, we're going to talk about two ideas. We're going to talk about segment addition, then we're going to talk about distance. Okay, so that's what's going on. Segment addition is just that, where you add two segments. If I had a segment, okay, and then another segment connected to it, and this was, say, 4, and this was 5, then this segment's 4, this segment is 5, then how much is this whole segment? Well, of course, it's 9, right? Okay, so we're starting to put letters on here, or points. So that's like A, B, and C. So AB plus BC is equal to the whole thing, AC, right? Okay, we knew that this one was 4 and this one was 5, so these two added up to be 9. Okay, so we can set up stuff based on the idea that B is in between A and C. Okay, between is a key word. It doesn't mean like in the middle, because that would be a midpoint. So we're just saying that B, this point right here, is somewhere in between A and C. And whenever it's that way, then you're going to use segment addition, which is to add part plus part to get the whole. Okay, part plus part to get the whole. So that's what we're doing. Okay, so if B is between A and C, then AB plus BC is equal to AC. Okay, this part plus this part is equal to the whole thing, right? Part plus part equals whole. All right, so down here, they've asked us to draw this picture based on K being between J and L. Okay, so I'm going to draw me a picture and put K in between somewhere. It doesn't have to be in the middle. Shouldn't be in the middle, actually. It'd be easier just to keep it away from the middle. So that's going to be J, and that'll be L. Okay, so the conclusion based on this idea is that the first part, JK, plus the second part, KL, is equal to the whole thing, JL. So we write that. So JK, the first part, plus KL, the second part, is equal to JL, the whole segment, right? Okay, this is called segment addition. Okay, here's where we apply it and do a problem. Okay, S is between R and T. Well, that's the picture. They don't always draw the picture. You'll have to maybe draw it for yourself. I mean, once you get it, then it's this part plus this part is equal to the whole thing. And you set up an equation and solve, but we'll talk about that later. Okay, so S is in between. Now it says RS is 2x. So this part is 2x. This part ST is 5. Then it says the whole thing from here to here, the whole thing RT is 31. Okay, so couldn't you make an equation? Because this plus this equals 31, right? So that's what we do. We say 2x, which is RS, plus ST is equal to the whole thing, RT, which is 31. So 2x plus 5, that's these two parts, is equal to the whole, which is 31. So now I can solve for x, okay? So I subtract 5 from both sides, right? And then I get 2x is equal to 26, and then I divide by 2, and I get x is equal to 13. Am I done? No, they're asking for RS. Okay, RS is 2x. Okay, now I found x, so I can just plug in 13. I mean, I could do it right here too, either place. So 2 times 13 is 26. So RS from here to here is 26, and this is 5. I know it's not drawn to scale here, okay, but RS is 26. X helped me to find RS. Okay, so next problem, it's the same segment addition type of problem, but they use different wording. They say E, F, and G are collinear. Do you remember what collinear means? Yeah, all the points are in a straight line, okay? So E, F, and G are collinear, but point F is between E and G. Okay, so we can put a point F is between E and G. So that's E, and that's G, okay? So we draw this, and then EF is 4x minus 20. Okay, FG is 2x plus 30. And then the whole thing is this 100, right? Okay, from E to G, all the way to G is 100. So you could easily make an equation, right? First part plus the second part equals 100. Just don't forget to put the plus sign in between. Okay, so 4x minus 20 plus 2x plus 30 is equal to 100. Now here's where a lot of people start trying to subtract 2x from these two guys, but that's not on either side of the equal sign. Remember that you've got to combine everything when it's on the same side, right? The 4x and 2x, we can gather them together. They're like terms. 4x and 2x is 6x, right? Okay. Minus 20 plus 30 is, if you use the calculator, you get plus 10, right? Okay. So we combined everything we could. Now we can't combine those, right? So now we start working with the other side. So we put the 100 here, and just like always, it's a two-step equation. You get rid of the 10 first, okay? Minus 10, and that's gone. You get 6x equals to 90, and then divide by 6. When it's beside it like that, you divide. So you divide, and you get x is equal to 15, okay? Now, that's part of the answer, but they want EF. Okay, that's the first part. See it over here? EF, all right? So we're going to take the 15 and plug it in here. So 4 times 15 is 60, minus 20 is 40. Okay? And this has got to be 60, right? Because they have to add up to 100, right? But we can prove it. Okay, let's plug 15 in here. So 2 times 15 is 30, plus 30 is 60. Okay? Very good. So that's segment addition, all right? And what you're going to be doing is these 4 problems, right? And I'll have that online. Anyway, so these are the 4 problems that you're going to be doing to practice on that. Okay, so now I'm going to turn this over and start working on distance. Okay, distance is how far it is from one place to another, obviously. Okay, now on a number line, it's real simple. From here to here, we basically, the way I think is I go to here, sorry. That's 7, and then 3 more. So 7 and 3 is how much? Well, it's 10, right? So that's 10. Now remember that a distance can never be a negative. It's always positive. Even if you're going backwards or down or whatever, you're still going somewhere, okay? It's always positive, you know, even though it seems like it's negative, but it's not. I mean, if I go backwards, I'm still going 10 steps. It's 10 feet or whatever it might be, okay? Okay, this one's simple too. I like to do 3 plus the 9, right? So 3 and 9 is 12. Okay, remember that, well, let me show you this. At AB, whenever I have the line, then I'm talking about the name of the segment, okay? Segment AB. But if I don't have that little line over the top of it, then I'm calling this a measure. In other words, a number like we had here, 12. Okay, so if it doesn't have a line over the top, it's a number. Okay, now that's simple stuff. This is where it really gets into what we really need to learn. Okay, we can find distance on a coordinate plane using either the Pythagorean theorem or the distance formula. Strangely enough, they're the same thing, just look like they're different. So we would find this distance, okay, from one point to another, or the length of this segment. 2 ways to say it. All right, so we're gonna use the distance form. Well, not the distance form. We're gonna use the Pythagorean theorem first. Okay. Now I'm gonna derive what we're gonna use, which is a squared plus b squared. Okay. We're always gonna use that to solve these types of problems. Okay. So let me show you how that worked. Okay. Remember the Pythagorean theorem: a squared plus b squared equals c squared. Well, if you want to get this to where it's C, and that's the hypotenuse, right? Okay, let me draw this real quick. Okay, so that's now a right triangle, right? So if I wanted to find this C, right? This is an A and a B. Doesn't matter which one's A or B, but this one has to be C. If I want to find C, then I need to take square root of both sides, okay? The square root of C squared is C. Take my word for it, and I'll show you how the math works later in the year, okay? So what you're left with is a squared plus b squared. So from now on, whenever we have a graph, we're going to make a little right triangle if we want to find a horizontal line. Because, I mean, not horizontal, but a diagonal line, okay? Horizontal and vertical are easy. You just count. Like this is 1, 2, 3, 4, 5, 6. So that's 6. And this is 1, 2, 3, 4. All of those are fine. But if I want the distance from here to here, I have to use this formula, okay? So basically, it's like I'm finding the hypotenuse of a right triangle. So I'm going to plug these two numbers in, 6 squared plus 4 squared. Okay, it doesn't matter if the 4 squared goes first or second. And then I'm going to use my calculator. Okay, let me put it way up here so you can see what I'm punching. Okay, so it's on, and then now I'm going to clear that mess and say second x squared. Okay, second x squared, you can tell that's how I get that square root sign. Okay, and then I say 6x squared, okay, plus 4x squared, and then I hit enter. And my distance is 7.2, okay, and I usually round to the nearest tenth. Okay, so the distance from this point to this point is 7.2, or the length of that segment is 7.2. See how I did it? Okay, so now we're going to do this one, okay, but we have to plot our own points, okay? Remember left or right for the first number? So -5, you go 1, 2, 3, 4, 5, and then it says -4 down, so you go 1, 2, 3, 4, and you're here. That's the first one. And then the second one, you go -1 and then up 3. Okay, so we're going to make our hypotenuse. That's the distance we're going to find from point to point, or the length of this segment. And then we're going to make our right triangle. Okay. All right. And then this is a 4, and this is a 1, 2, 3, 4, 5, 6, 7. Okay, so a 4 and a 7. So you take the square root of 7 squared plus 4 squared. Okay, punch it into the calculator. Second x squared, and then 7 squared plus 4 squared is 8.06, which is 8.1. All right, so that's equal to 8.1, and that's the length of that segment, or the distance between the 2 points. Okay, so that's the Pythagorean theorem way. But what if you don't have a graph? If you don't have a graph and you have these 2 points and you have to find the distance between them, then you have to use this Pythagorean theorem. Okay, so what do these 2's and 1's down here mean? They're just addresses, okay? Isn't it true that these are just 2 points, right? They both are x and y, right? Okay, now this one is the first point, okay? So that's why they put 1's on this. This one is the second point, okay? The second point. So that's why we put 2's on it. So basically, this is the second x, this is the first x. So you got second x minus first x, right? So I'm going to subtract these 2, okay? So I'm going to put it into the calculator. Let me do it over here, so I have room to do one more problem. Okay, so parenthesis, then I'm going to put the 3 minus the 2. 3 minus the 2, parenthesis squared plus parenthesis. Now I'm going to subtract the y's backwards, okay? So I'm going to say 4, and this has to put a minus, so I'm going to put a minus. Then I see the -2. So I'm going to put minus a -2 and square it, okay? I can actually put this in just like this into the calculator and have it work. Or minus a minus is plus, so I would have 4 plus 2 here. But I'll just go ahead and punch it in just like I wrote it, okay? So I'm going to say second x squared, which gives me the square root, and then I put the parenthesis, then I say 3 minus 2, parenthesis x squared plus parenthesis 4 minus a -2, parenthesis x squared, and everything's in there. So I just hit enter, okay? That's 6.08 or 6.1. So this is equal to 6.1, okay? And that's the distance from this point to this point, right? Okay, so let's do it one more time. I'm going to just pick something out of the air and make it up, okay? Let me see. How about a -6 and a 4, and let me see, a 6 and a 3 or something. I don't know, okay? So we're supposed to plug into this formula, so I'm going to subtract the x's backwards, okay? This one was x1 and this was x2 over here, right? So I'm going to subtract those backwards. So I get a 4 minus a -6 squared, okay? Now this is the y1 and this is the y2, right? Because then this is the first y, right? First y, and this is the second y. So I'm going to subtract them backwards. I'm going to say 6 minus 3, okay? 6 minus 3 squared. And then punch them into my calculator. So second radical, parenthesis, 4 minus a -6, parenthesis, x squared, plus let me see, parenthesis 6 minus 3 parenthesis x squared, and hit enter. And I get 10.44, so it's 10.4. And that's the distance between these 2 points. Okay? So, anyway, have a good day.